Hello, everyone. Today we're going to talk about the Media Access Control, or the MAC address. We're going to discuss the format and the details of a MAC address. We're going to discuss the Layer 2 frame format, and we're going to discuss why the MAC address organizational unit identifier is so important in the MAC address. Right here, we see an example of a MAC address down here where it says physical address on this screenshot we got from a command prompt. Layer 2 addressing, commonly known as the MAC address. This unique identifier is on every network NIC card and device interface. Each MAC address consists of 6 groups of 2 hexadecimal digits separated by hyphens or a colon. They are 48 bits long and use a base 16 numbering scheme of 0 through 9 and A through F. An example is shown here in this slide. The MAC address is assigned during manufacturing of network equipment with NIC cards or network interfaces. Each manufacturer is given an OUI, Organization Unique Identifier, assigned by the IEEE. The OUI is the first 6 digits of the MAC address. The last 6 are assigned by the manufacturer. Vendors are trusted to assign a unique number to each device, so no 2 MAC addresses are the same. The data link layer takes a packet from the network layer and breaks it into frames. The network layer is a layer above the data link layer, so the data is sent down from the network layer to the data link layer. The header ENIS layer provides the source and destination MAC address that is used to send traffic through the network. It is a data link layer that will convert the data into binary digits or bits, such as the ones and zeros in the binary numbering system, and then prepare them for the physical layer. Now we have an example of a Ethernet or data link layer packet here, and then you can see the header, and it has the source, the destination and the source MAC address, and it has a CRC at the end, which is called the trailer. Hexadecimal to binary conversion. That is what we just discussed earlier. That is what the data link layer does. It takes the hexadecimal MAC address and it converts it to the binary numbering scheme, which is a base 2 numbering scheme. So as you can see here, we have an example of a MAC address up here, the 00, the 0C, the 4T2, and the 28. And then below that, we have the binary conversions of these MAC addresses right here. As you can see, they're all ones and zeros in the conversion. These 8 digits right here are each called bits. So you got 8 bits right here, 8 bits here, and 8 bits here. The 0 means the bit is off, and the 1s mean the bits are on. And as you can see, the string of bits is what is sent down the Ethernet link or onto the physical link from the data link layer. So it converts these top numbers here, the OC, the 42, the 28, and it converts it to the binary ones and zeros. In the previous slide, we saw the MAC addresses on the top and the binary number conversion on the bottom of the numbers. So here we're going to take a look at the binary and the hexadecimal numbers. So we got a table here. On this side, we have the hex number, which is 0 through 9 and A through F. So that gives us a total of 15. We have the binary conversion over here. And then over here, we have the hexadecimal or the hex numbering scheme, hexadecimal numbering scheme to the decimal. So the zeros and the ones, they all match up all the way down to 9. When you get to 10, hexadecimal is the A, in decimal is the 10, 1 and a 0. Hexadecimal B equals 11, 12 equals C, 13 equals D, 14 equals E, and 15 equals F. Now, each bit, these 4 bits, they have a value. So when we start from the left, the value is 1, 2, 4, and 8. Yeah, I got the bit values down here. 1, 2, 4, and 8. When all the bits are off, that equals 0, as you can see up here. When all the bits are on, that equals F in hexadecimal or 15 in decimal. So we got a conversion here. Say our MAC address begins with 9A. So in the binary system, the 9 is 1001. So that's binary 9, 1001. And you read that by saying the first digit here equals 1, the second digit is off, and the third digit is off, and the fourth digit equals 8. 8 plus 1 equals 9. And then our next number or hexi number is A. So A equals 10 in hexadecimal. So to read that in binary, the first digit of 1 is off. The second bit is on, which equals 2. The third bit is off, and that bit is the 4 bit. And the fourth bit is on, which is the 8 bit. The value of that bit is 8. So 8 plus 2 equals 10 in decimal, and 10 in hexadecimal is A. So this is the binary conversion of 9A. And as you can see, when it's strung out in 8 bits, this is what it looks like. To the computer, this is what it sees. It sees 1, 0, 0, 1, 1, 0, 1, 0. And to the computer, that means 9A. Let's say our next number in our MAC address, our next set of numbers are 8C. Now you can see 8 is 1, 0, 0, 0. So the first bit is off, second bit is off, the third bit is off, and the fourth bit is on, and the value of that bit is 8, as we can see right here. And then our next hexi number is C. C equals 12. So we have the first bit is off, the second bit is off, the third bit is on with a value of 4, and the fourth bit is on with a value of 8. So that gives us the number 12. 8 plus 4 is 12. So this is just a kind of quick run through on the conversion. Most people will have to read and study this a little bit more. We're not used to a binary system, and we're certainly not used to a hexadecimal system. We were all taught the decimal system. When we went to school, most of us have been taught the decimal system, which consists of 0 through 9. And then we have place values here. So let's say in this particular number, the 10, the 0 is in the 1's place value, and the 10 is in the 10's place value. So that makes it 10. And over here, the 11, the 1 is in the 1's value, and the 1 is in the 10's value. So you get 10 plus 1 equals 11. And the same thing over here, so forth and so on. On 13, the 3 is in the 1's value, and the 10 is in the 10 place. The 3 is in the 1 place value, and the 10 is in the 10 place value. 10 plus 3 equals 13. Hexadecimal is a little bit different. You can see it's a base 2 numbering scheme. So you got 1, and then you have 2, and 2 times 2 is 4, and then you have 4, and 4 times 2 is 8. I just wanted to touch on this. You're going to do a lot more studying on this, and we're going to do some more detailed videos on how to convert from hexadecimal to binary.
Hi everyone, thank you for watching my daddy's video.